Hey folks, Adam Dupay here, and today we're gonna be playing through the pwnable.kr, and this is going to be a live hack. I'm gonna be working on the input challenge, and this is actually something that I haven't solved yet. So this isn't a walkthrough necessarily. It's more of a me trying to live hack through a challenge. So let's see how this goes. So when we SSH to the machine, we can see, so we're SSHing input2 at pwnable.kr. The important thing that it tells us is, Mom, how can I pass my input to a computer program? So presumably this challenge is going to have to deal with how we pass in input to a process. So if we look, so we have our program. It says, welcome to pwnable.kr. Let's see if you know how to give input to a program. Just give me correct inputs, then you will get the flag. So it seems pretty straightforward. So I've already copied down the source code to the machine, so let's look at it here. So we can look through this. So this is the C code. We can see this message that we just saw printed out. The first check, if argc is not equal to 100, returns 0. So this means that we have to execute this program passing in argc as the value there. So we need to pass in, so remember the first argument to argv is typically the name of the program to execute, so that's argv0. And so we'll need to pass in 99 arguments. Let's see, other interesting things. If string compare argv a is if that's 0, then return 0. So this is interesting. So they're indexing into the argv vector using a character. So that will presumably, let's open up a new terminal here. So going into the terminal here, man, ASCII. So if we look, the character of A, so I don't memorize these things, these tables, so I always have to look them up. So we have A. So A is going to be decimal 65. So at the so it's a 0 index. So at the 0 index, 65th index, we need to make sure that that is equal to a null byte. So remember, this is a string containing null. So this would be a string of length 0. So this is interesting. Then the next string compare argv, so this will be 1 right after the A, needs to be 20, 0A, 0D. Why is this interesting? Well, 20 is a space, 0A is a new line, and 0D, I believe, is a line feed, but we can check that very quickly. It's a carriage return, so it's a /r, so it's a /n and a /r. So now we go back and say stage 1 clear. Okay, that actually seems like that should be very easy to pass, and we should be able to do this just from passing in input. So we could actually do this just from the command line. So, and we can see there's actually helpful comments here. So this is about manipulating input in terms of argv. And here, this next one, it looks like in terms of standard IO, so standard input output. So we can see there's a character buffer of size 4, allocated on the stack. It's reading from file descriptor 0. So if we remember, this is actually passing in. This is interesting. So it's reading from standard input into the buffer. And it's reading in 4 bytes, and it's checking to make sure that those bytes are 00, 0A, 00FF. And if it's not, then return 0. So that's ensuring that the standard input to the program is this. Now another interesting thing is now it's reading from file descriptor 2 the buffer, and it is calling memcomp on that to compare that to 00, 0A, 02FF. 4 returns 0, so it's going to say print stage 2 clear. So this is an interesting check because it's reading from what is traditionally, remember, 0 is standard input, 1 is standard output, and 2 is standard error. So standard error is usually something you write out to, but here it's reading from that. So we're going to have to manipulate this so that it can actually read from standard input. And then here we have the environment. So now it's reading from the environment variables. So here it's saying, hey, compare get env, so get environment, DEADBEF, compare that with this value. So read in the environment variables this value. So we have to be able to manipulate the environment to include these parameters. And of course, the trick here is that these are not ASCII characters. So this is going to be something that we'll have to create. The next stage here, it's interesting. So the next stage here is a file. So open up a file whose file name is a new line character and read that file. And then read 4 bytes from that file into buffer, that same buffer again, and check is that buffer all zeros. So we'll need to create a file with the name 0x, with the name of a new line character. And inside that file, we need to put 4 zeros. So this is actually pretty interesting. To pass stage 4. And finally, here we have our network. So we have a network section. And so here it's going to create a socket. It's going to use, let's see, argvc. So the one after, so we do ABC, it's going to do argvc. It's going to set that equal to the port. So it's going to listen on this specific port. And what is it going to do? It's going to listen there. It's going to accept. It's going to receive 4 bytes. We need to send it DE, AD, BE, EF. And if we get that, then it should be stage 5 clear. I'd have to look up I'm going to guess off the bat that this is going to be a TCP packet. One thing we could do is just rip out this code into a C file, compile it, execute it, and see what it does to see what kind of socket it's listening on. But I'm going to go ahead and guess that it is going to create a TCP socket. If not, we can easily change that from UDP. And then it will output us the flag. So it's going to call system/bin/cat flag. All right. So how do we do this? So my initial instinct here is to always maybe create like a Python program or a bash script that will set up the environment here. But one thing I'm worried about is how to set environment variables that are arbitrarily named like this. So this is something that we can easily do with a C program by calling, so an important thing that we're going to do is execve. So execve is the system call, and this is how you actually execute another program. And this is what, when you're typing in bash or any other shell, this is actually what gets called. So here we have execve. We can pass in the file name that we want to execute. We know exactly what the file name is. We can create an argv vector, and here we know we have to pass it 100 variables, an array of 100, and we'll need to construct an environment pointer that has what we want in there. And so we should be able to execute this, and so that way we can call this program passing in the exact arguments that we need. So this should be good. So we're going to go with that because we should be able to create all of these values. So we should be able to create the argv, we should be able to manipulate the standard input and standard output so we can pass in variables to standard in and standard out. The environment pointer, that should be easy. We'll construct the environment pointer to deal with that. And we should be able to actually just use this to create this file, this new line file. So we'll basically use the reverse code here. So with that, we've got to start executing. So let's create a solution.c file. I'm going to rip these headers. So rather than thinking about what headers I need, I'm just going to use exactly what these people need. What is that? There we go. I will also need, because I know I'm going to call execve. So again, I always love using the man page. Because it's going to tell me, hey, look, this is the header that you need in order to call this program. So here I have this. Now I'm going to do my int main, int argc, character pointer, argv, and I actually don't care about the environment for this guy, so that should be fine. So this is going to, so basically what I'm going to do is create essentially a new argv vector. I will eventually need a new envp pointer, because at the end of this, what I'm going to do, I'm going to call execve. Now, what do I actually want to execute? So it is called input. So let's call it, so this will need actually the full path. And so because I want to test it first, let's do, because I have it here, so I can run this program locally. So here I have input. So this is actually a ridiculous path, but let's use it anyways. So a key thing, and let's make this a character pointer path. We'll call it executable / input. And that's the way I can change it when I copy and paste this to the actual source code, to the server. I can change this to whatever I want. So now I have my execve, exe, and now I'm going to pass a new argv and new envp. So execve, what that's going to do, that's a Linux system call. It's going to completely replace this process by executing the other process. So I urge you to look at how the process works, how this execve thing works, and look at system calls and how they're implemented. So, and basically what I'm going to do is I'm going to try to create this program exactly as if what this program is looking for. So I'm going to have an argv section to set up argv properly, standard IO / fd file descriptors, create the environment correctly, create the file, and network. I'm going to put a question mark here because I think I'll be able to do this from another process. So because I know it's going to wait for this, so I can just create from another process. I can connect there, and then I can pass the parameters that I need, the input to pass this network check. So I don't necessarily know that I want to do this, in this C code. All right. So one thing that we can get off right off the bat, and we can be, and if we go back to the man page, we should be able to see that these are, so here it says environment, argv is an array of argument strings passed to the program. By convention, the first of these strings should contain the file name associated with the file being executed. Environment pointer is an array of strings, conventionally of the form key equals value, which are passed as environment to the new program. Both argv and environment pointer must be terminated by a null pointer. So this means a null pointer. So this is going to be, I'm going to set this to basically an array of, I need to figure out how I want to do this. So the environment pointer, I really only need one of, and this is where my syntax is going to come in handy, or going to be messed up. So you want one more than you actually have. So I can set environment pointer 0 is going to be equal to, and I know that, I'm just going to pull it up here, input.c. I know that I want, so what I want in my environment pointer is I want this value is equal to this, and I don't want that. So that's going to be the first key value pair in my environment pointer, and I actually don't want anything else in my environment pointer. So environment pointer 1 is going to be null, and that should pass that check once we get there. At this point, I'm going to compile this to make sure I'm on the right path. I'm not quite sure about my syntax here, so I like to compile as I'm going. GCC solution.c. And what happened? So we can actually call strace to see it calling, let's see, execve with this file, null, and with one variable. So a environment pointer that contains one variable. So that's awesome. So we saw that that works. Oh, good. So my syntax did work there. So now we know, what do I need for this? I need space for, well, I need the argc to be 100. So I actually need to pass in 101. Remember, if I come up here, argc is not equal to 100. So I need to pass in 100 values, which means I need to, I will need to, what I'm going to do is, let's say to set this up, I equals 0, I less than 100, I plus plus. So it's going to loop over all of them. Basically what I'm going to first do is just initialize everything to the I'm going to initialize everything to the empty string. So I'm going to say new argv1, argvi is equal to the empty string. And then I'm going to say new argv100 is equal to null. So this will set the last element in the array equal to null. And let's see, does this check out? It's going to be 100, so I will never be 100. Yes, so the first 0 through 99 will be set to the empty string. Now I can actually just make sure that I can do exactly what they're doing here. So I actually don't need to know where exactly this is. All that I care about is that it's going to be set to the correct values. So if I do this correctly, and we know from looking at, I already need to set, I need to set this to some port. So let's do 8080, just a random port. Now I can actually test this because I have, if I'm correct and I did this correctly, I will get to this printf stage 1 clear. So if I go here, I should be able to, you always got to compile this. Sometimes that bites me, but stage 1 clear, great. So we passed 100 arguments there, and we actually know, what is it waiting for here? Well, it's waiting for reading in from standard input. So we want to be able to now change the standard input that we're going to pass to this program. So the next step is to get past this. There's a couple arguments here. I think maybe an easy one is going to be basically change standard input for this executing program to read from a file. So what we'll do in our solution is we will write out a file that has these bytes, 4 bytes, 000A, 00FF. And then what we'll do is we will redirect the standard input of these exeve programs so that it's thinking that standard input, the file descriptor 0, is that program. And then, so I'm gonna have to actually dig into and figure out how to do that. It's been a while since I've played with, it's probably in the dupe family of keywords, so that should be fun. So, but I have to go for a second, so I will be right back. All right, so now what we want to do is we want to bypass this check of the program. So here we're going to need to create 2 files and in this directory. And what we're going to do is put these contents in those files, 4 bytes into those files. And then we are going to change the file descriptor so that file descriptor 0 reads from that file and the other file descriptor. So we'll need 2 file descriptors. Int new standard in equals open, and I'm gonna need to look at the man pages for this because I definitely don't remember how to do all this in C. I will need a different section of the man page too. There we go, flags. So, and let's make sure we include these files. They may already be included, but hey, it doesn't hurt to actually include these. All right, good. So int open, we want the path name to be /, we'll just call it first, it doesn't really matter. Flags though, we're gonna want to look at the flags. We want to write only, we're gonna write out this file, write only. And then we are going to call write on this file. So we're going to do man open to write. We are going to write out. So this is going to be pretty easy. We're going to do exactly the opposite of what's being happened in here. So we're going to call write to this file descriptor new standard in the buffer. So we're going to want these bytes, and it's super easy if we just copy these exact bytes. That will make it the easiest. And we're going to write 4 bytes into that file descriptor. Great. int new standard error open dot slash second. Again, actually, now that I think about it, we'll probably want to change the change how we open. We may, now that I think about it, we're probably going to want to seek on these files, because after we write, the file descriptor will be at the essentially the 4th or 5th bit. So we're going to want to, yeah, I think we're going to want to seek, because our child is going to want to read from it. So if we don't open up these files and file descriptors so that we can read from it, we're going to have a bad time. So now let's write to new standard error. Did I add that in here? I don't know, but let's check this. Write that, those 4 bytes to that new standard error file, which will be second. And then I think I'm right about the seek. I think it's called fseek. No, okay, well, let's just look for seek. Let's see if there's just a seek function. Fseek, okay, fseek, so we want to, man to open. So, here we say read, write, lseek. So there we go, that's what we need to do. So lseek reposition, so what was tripping me up and throwing me off is that fseek includes a file pointer, and here all we have is a file descriptor, an integer, so these aren't the same thing, so we want to make sure we're using the right file. So lseek new standard in to offset 0. What in the world is this whence parameter? Lseek function repositions the offset of the open file associated with file descriptor fd to the argument offset according to the directive whence as follows. Seek set, offset is set, current. Oh, so you can seek based on the start of the file, like set it to a like absolute file location. You can set it based on an offset. So here we want to make sure. So it's important to read the documentation. Lseek new standard error 0 seek set. Good. So now those are seeked. So now I need to figure out how I want to duplicate. So the idea is how I can so now I need to read this code and figure out how I can get the file descriptor set up properly so that I can make sure that standard input is now reading from this file and standard output is, or standard error is reading from this other file descriptor. And I have not done this before, so let's dive in. So this may involve some Googling, and I think I'm just going to record this just so you can see kind of what the process is like. Dupe2, so okay, so dupe just gives us a, creates a copy of the file descriptor. Dupe2, for the same task dupe, instead of using the lowest numbered unused file descriptor, it uses the descriptor number specified in a new FD. The descriptor new FD was previously opened. It is silently closed before being used. Oh, cool. So atomically, equivalent functions, race conditions. So I think I can just use, so I think I can call dupe2 with the old, creates a copy. Okay, so the old file descriptor. So I want new standard in. So this is my new file descriptor. Let's see, I want to, this is interesting. So what's gonna happen when it outputs those bytes? Well, I guess we shall find out. So dupe2 is gonna be new standard input, and I want it to be 0. So I want standard input to be from there. So now this should duplicate. So this new standard input should be standard, should now be file descriptor 0. So it's going to close it before reusing it. And then we're going to do another dupe2. We're going to want our new standard error to be file descriptor 2. And now we know that if this compiles, we know that this should work. So if we see, or if maybe we actually may not see it, it may go to that file that we just created first. We may see this stage 2 clear. So let's try this and see what happens. And we may need to debug it if something goes wrong. So compiles fine without errors. Always a big shock when that happens. Stage 1 clear. And let's look at, so those files did not get created. That's interesting. Let's see. Solution.c. Called fopen. I didn't close those files, but that's because I don't want to close those file descriptors. Can I write files here? Yeah. Okay, let's create these files and see what happens. So first and second. I shouldn't need to do this, but let's do it anyways. Oh, that's awesome. Okay, so it looks like, so we can see that part of the problem is that we did not create those files first. So that means this is actually going to fail when we try to do things. So what we should be doing here, so we actually saw that we passed stage 1, stage 2, and stage 3. So stage 3 was the environment pointer. So that means that's good. We set up all that stuff correctly. That's awesome. Now we just want to make sure that we actually create these files. So how can I just... Let's see. Oh, there we go. I want ocreate. If file does not exist, it will be created. So this is the mode that I want. So I'm going to or that. And now we can see I don't have those files. Compile. Boom. Stage 1, stage 2, stage 3 clear. So that is awesome. So then stage 4 is this file descriptor. So we need to create this file. And again, this is going to be actually pretty easy and straightforward. What we're going to do is just do exactly what we did before. So we going to open this file. We're going to call it x0a. I think that'll work. We'll see what happens. That's going to be annoying to have that file there, but hey, we will do the best we can. And what we're going to do is the same thing. Of course, I don't want to call this new standard in because that's going to may mess things up. So this would be, we'll call this new line because it's a new line file. So we're going to write out to new line this buffer 4 bytes, and I'm going to call close. Yeah, so close that file descriptor. Cool. All right, so we should be able to get past that. Let's GCC it. That's interesting. Why did that not work? Oh, weird. Interesting. Look at the permissions for second. The permissions are nothing there. I have no idea why those permissions are getting set like that. Oh, I just deleted that file. Okay, SCP, the actual program. Good, so that comes back to us. So even the first is not. That is very interesting. Oh, I wonder if we can. Let's find the mode. So let's add that there. the argument flags. Let's include that. Okay, but what about, it doesn't say what the mode parameter. There we go. Mode specifies the mode to use creating a new file. So it must be applied when, Oh, interesting. So it's just reusing. So that's, okay, so these are just Unix permissions. So these would be really easy. So interesting. So basically from this create, I bet it's the reason why those things are different is because it's using the value on the stack. And so they're just using whatever was there. And we will be super generous and just give everyone permissions to these files. There's the other open 0777. Sweet. All right. And now the problem is I have this. Yeah, I have this now. I have this file, this new line file there that has bad permissions. Let's just. Yeah, so the problem is now we have first and second are. Man, they're not quite correct, but hey, I think we'll maybe take what we can get. Maybe I need 0. These permissions are funny. Let's try that. Second. First, second. Nope, that didn't change anything. Okay, well, that's strange. We'll just ignore that for now. Looks like some of the permissions are getting set correctly, so that's good. The problem is now I have this new line file, so let's see. Yes, so I want to delete this file now. So first I need to unlink this file. And that should delete it. There we go. So I got stage 1, stage 2, stage 3, and stage 4 clear. And since we actually passed stage 4, we're on the network. So that means we can actually use netstat here to see netstat NLT, so listening TCP. We can see, so we're listening on port 8080, we know it's TCP, so now we can actually just say echo, or let's use Python to be a little bit nice. So Python-C print print this. And we're going to pass that to netcat localhost 8080. Stage 5 clear, so now we should get the flag. Awesome. So here's the thing, we don't have a so we can actually get rid of this unlink business here because we don't need that anymore. Although I'll have to run this to get that file out of the way. So this solution.c, we should be able to run this. So what I'm going to do, I'm going to, oh, there's a lot of people have found the wall command. Maybe I'll find something to tell people about how to do this. So let's go into our own directory. Touch. All right. So I'm just gonna, this is a poor man's copy paste. So we're gonna copy paste this here. We're gonna run vim on this solution. Remember, we need to change this exe value so that the proper thing gets its input here. So I believe we are in /home/input2/input. And the other thing we have to think about is, that's fine, I don't care about my bin info file. The other thing we need to think about is when we cat, it's going to call bin cat flag. And remember, all these files that we're creating are in our local directory. So I'm going to have to actually SSH there so I can properly get that input. So let's do SSH input2. So now I have 2 shells here. So the problem is we're going to cat out. Once we get this correctly, it's going to use the current working directory to find flags. So it's going to do bin cat flag. Of course, the problem is there is no flag. So what we can do is create a symbolic link to home input2 flag, call it flag. And now when we try to /bin/cat flag, of course we can't do this because we don't have permissions, but the executable that we're going to execute will have these permissions. So I can call gcc wall solution.c and should be able to call a.out. We pass stage 1, stage 2, stage 3, stage 4, and then we'll go here and we will copy that same Python command that we had here. Go back to there. There we go. So here should be our flag. Mommy, I learned how to pass various inputs in Linux. Let's pass it into the flag parameter. And it will tell us to log in first because it's been too long since I did this. So I will log in. Log in OK. Great. Input. And there we go. That's how you solve this challenge. So hopefully this was helpful in understanding how to think about these types of challenges. So that was a lot of fun, and I'll see you next time.